What's Gucci, everybody? Again, it's Buzo Builds, and we're back trying to make the Tic Tac Toe game. So right now we're able to basically, well, I guess I can just show y'all. Let me start the game. So basically we're able to generate a game, and we got a grid, and we can click on places, and you see wherever we click, there's going to, in the 2D matrix that's representing the grid, it puts in information, in this case strings. If you see the little print statement stuff over here, it's showing us basically what's in the 2D matrix now. But that's kind of bumpy. I mean, not bumpy, I don't know. It's kind of like we want to be able to draw the actual characters, well, the actual X and O's on the game display. So let's go ahead and do that. Really, the main plan is to basically anytime during the game loop, right? At some state during the game loop, we want to redraw the whole screen. And part of the way that we're going to draw the whole screen is by looping through the 2D matrix and seeing if there's either an X, an O, or a null in it. If it's a null, we don't draw anything. If it's an X string, then we draw an X, and if it's an O, we draw an O. Right now, since I'm just focusing on the X's just to get the functionality down, I'm going to go ahead and just make a draw X function. Alright, so let's go ahead and make this draw X function. I guess we can go ahead and say public void, because we're not returning anything, public void draw X. And for this function, we want to get what position of the 2D matrix our incrementer is at, so we can know where exactly to draw the X on the grid. So we're taking an int X, int Y, and we also want to take in this 2D graphic object. Down, where? Jeez. Yeah, this 2D graphic object, because that's what we're going to be using to actually draw the line. So we want to say graphics 2D and G2. Reference name doesn't really matter, but it's giving me a funny look. I could have sworn it's called graphics. Oh, capital D. Okay, so now that we have that, we basically want to, wherever we are on the graph, in the 2D matrix, we want to draw an X, right? So the 2D matrix and the actual display, I guess I can pull it up real quick. This actual display, it's not like a one-to-one mapping, because 2D matrix is just 0, 0, 0, 1, and yada yada yada. But since we know that each third is about 133 in distance, we can basically just say whatever part we're on, we basically multiply that by 133 to actually represent where exactly each point of the X is. That's kind of weird to explain. Let's say, because basically, actually, I guess let me just start typing in the function, and then I guess it'll make more sense. So we want to do g2.drawLine. Oops, dang, my computer is being extra slow today. g2.drawLine. Actually, before we even do that, we want to set g2.color to be black. I think it's already black. Is it? Where's this paint component class, bro? Oh, it's right over there. Anyways, it might be g2 dot. Is it black already? Yeah, it's already set to black, so we're gonna just say, okay, g2.drawLine. So drawLine basically takes in 4 parameters: x1, x2, x1, x2, x3, and x4. x1 and I said that wrong. x1, y1. They're basically points that represents the one part of the line, like the first point of the line, and the other x2 and y2 is the point that represents the other end. So since it's a line segment, so what we basically want to do is say we want because x is 2 lines. We want the first part to be wherever basically the top corner of whatever square it's on. So in order to do that, that's basically just x times 103 times y times 103. And this is because basically we're in some certain position, but since each square is 133 by 133, basically you just kind of map it out to the exact position it is. So let's say we're on square 0, 0, so that means that the top left of that square is 0, 0. But if we're on like square 0, 1, for instance, then the top left is going to be, the top left is going to be 0 and 133. So that's the basic concept. So you basically just have to imagine it in your head or draw it out, and then that's kind of the better way to understand it. Maybe I guess speed type this real quick. So yeah, of course the other line, because we're going from the top left to bottom right, so it's gonna be y plus 1 times 133, and then we want to do that again for the other line. This time we want to start from the top left, so we're going to say x plus 1 times 133, but since it's still the top, it's going to be y times 133. In this case, we're going from the top right to the bottom left, so our new x is going to be just x times 133, and our y is going to be y plus 1 times 133. So this function, once given the right parameters, this ain't supposed to be capital L. And given the right parameters, this should draw an X on the grid. So now we basically have a function that will draw X on the grid when it gets called, but we need to basically call it at the right times. But in order to actually do that, we kind of need to make our game wait for some input to be added into, to get some input before it actually does any processing. So in our main game loop, even before we reach this process input, we need to have some appropriate input. So I'm gonna call this portion wait for input. And really we want our main thread to basically sleep. So we can go while, and we're gonna make use of the game state to actually do this. So game.gameState. And then we basically just want the thread to sleep. We can make it sleep for, let's say, 100 milliseconds. So sleep 100 milliseconds. Yeah, it needs the no, not that one. Try this. Yeah, okay, so yeah, basically needs this whole try catch block, which is alright, sure. So basically our game, when the game state's in 1, and 1's going to basically represent waiting for input, is going to wait for 100 milliseconds. Then it's going to check again. Oh, is the game state in 1? It's going to wait for 100 milliseconds. It's not really the best way to do it, but it's good enough for this project. It's really just, we're waiting for a bit, and then we check, and then we wait for a bit, and we check. But the wait isn't so long that the player really notices, so and the thing is that, okay, well, how is our game state even going to get to 1? Well, we're just going to set it over here. Game state equals 1. So basically, after the whole game gets set up, we want the game state to be set to 1, so we can wait for some input from whoever turn it is. And we're gonna implement the whole turn functionality later. Right now we're just working with X to work on input stuff. So we're gonna set it to 1, and then we enter this loop, right? So theoretically speaking, well, actually not theoretically speaking, literally speaking, we're going to be looping forever, right? But on the mouse event, we want I wrote this? I don't even remember writing that. Game state equals 2. That's funny. But yeah, okay. Well, yeah, I don't remember. Maybe I did it before. But anyways, we wanted to basically, after we got some input, we changed the game state to 2. Meaning that we should no longer wait anymore. So basically, we set up the game, then we enter in this loop to wait for game input, player input. Then the player clicks, the game state gets set back to 2. So after this wait, it's gonna check to see if it's 1. It's not 1, and then it goes ahead and processes the input. So it basically adds wherever the click was into the matrix, right? And then at the moment we're just printing it out, but we actually want the game to redraw itself when after it processes the input. And the way it's going to do that is by calling the it would be game dot repaint. Yeah, because we want the whole thing to repaint. So we basically call the repaint method, and repaint method basically triggers the game window and all of its components, which includes the display, to run the paint component function. So all this is gonna run, even though we could make it for not run by like changing some games. So we might actually do that later. But right now our goal is to actually get the icons up on the grid. So we're going to increment through the matrix. For int y, I start with int y because y represents the rows, and that's like the first indice or sub indice or whatever for a matrix in Java C notation in general. So I know I'm more of like I start with X guy, but in this case it kind of seems reasonable to start with y. It doesn't really matter. So anyway, so int y equals 0 as long as y is less than. Since display is a inner class, it should have access to what is it called? The grid, yeah. As long as y is less than grid dot length y plus plus. And then again we do it for x, int x equals 0 as long as x is less than grid 0 dot length, which of course, as I said before, it doesn't have to be that way, at least for this case, but yeah, x plus plus. So we want to check what exactly is in that matrix cell. So if grid y x, if it equals our string x, then we want to draw an x, and we're going to do that by calling this function. So draw x, x, y, and g2. So for right now, that's just all we're going to do. So if it's that, it does that, and if it's not that, so if it's null, it's not going to draw anything. And then we can go ahead and put game repaint. So yeah, let's see how that works. Please don't break. Please don't break. Okay, well right now our game is waiting. We click, ooh, and we got an X. Hey, that's tight. We click over here, another X. Okay, another X, another X. As you guys can see, depending on the cell we click, right, it this is indexed by the matrix. It multiplies the stuff by 133 to actually get the actual position. So this is 0, this is 133, this is 266, this is on 400. So that's kind of the concept I was talking about. So you see, anywhere you click, it puts the X. Man, I was gonna say it kind of looks disgusting. We could make it a little bit smaller, but that might actually mess up the whole. It's cool. But yeah, so yeah, that's cool. We got the X displaying, and so at the next step is kind of just to work with the fix the turn functionality, so we can have O's on our grid. So